Welcome to video lesson number 2. In this lesson we'll be looking at graphs and specifically making scatter plot graphs for universal physics. If you remember, we were last taking a look at a scientist who was collecting data on a man going for a jog at 4 separate time intervals. He was then collecting the distances for how far the man had traveled during those times. If you remember, we created this data table from the data that we gathered from our scientist. If you have any questions about the specifics of this data table, please make sure that you go back and take a look at video lesson number 1. From this data table, we're now going to move into visually representing this in what we know as a scatter graph. Now, you might be familiar with this breakdown of the coordinate plane from math class, and I'll let you know that we're going to spend the majority of our time here in quadrant number 1. This allows us to work with positive numbers in both the x direction and the y direction. Most of the time we'll find that this will be perfectly suitable for what we need to do in universal physics. Now, that's not to say that we won't necessarily venture into quadrants 3, 2, or 4, but for right now we can just focus on quadrant number 1. So, if we're going to focus on quadrant number 1, we can zoom in just on that quadrant. Now, within that we need to identify a couple of things. First thing being the origin, our 0, 0 point, and then our x and y axis. Now, our x and y axis are actually representative of the independent and dependent variables. The independent variable going on the x-axis and the dependent variable going on the y-axis. In these instances, we'll be using time on the independent and distance on the dependent variable axis. The next step that we need to take is we need to give each axis a scale. We need to give it some relative size. Now, when we talk about scale and we talk about size, you'll notice that our distance axis goes from 0 all the way to 47. And our time axis goes from 0 all the way out to about 6.5. That means that I have to create 2 different scales on both of my axes. And that's absolutely perfectly fine to have those differences. We just need to make sure that we have them noted appropriately on our graph. So the way that I can take and create an axis is first by counting the number of lines and comparing that with what I have as far as my maximum value. If I take a look along the y-axis, I have 10 lines. I'll start by counting right here. This would be 1, then 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So I have 10 lines that I can work with on my graph, and I have a total distance, or a maximum distance, of 47.14 meters. Well, for my purposes, and you can certainly do this, to make my scale, I'm going to round that 47 up to 50. And when I have 50 and I divide that by my 10 lines, I'm left with 5 units for every 1 line. So that means that each 2 lines, or each one of my red lines, is 10 units of measure. Let's try another example, or let's model another example here on my x-axis. My x-axis, if I count it out appropriately, leaves me with 14 different lines that I can use. And if I have 14 lines, let's again round up to 6.5. Well, let's just go right to 7. I use 7 again just because that whole number makes my life a little bit easier, and you'll notice my 7 is larger than my 6.3. I always want to make sure that my scale includes, or the maximum value on my scale is larger than the maximum value for the data that I have. So if I round to 7 and I have 14 lines across the bottom, or across my x-axis, I can create a scale where I have 0.5 for every 1 line. All I did, again, was take my maximum value of 7 and divide it by the number of lines I have, which was 14. So if each line is 0.5, then what that allows me to do is each red line then is 1. As I go through and I make my scales, I want to do my best to use what can be known as easy numbers. Okay, using 0.5 as a scale, using 1 as a scale, 2, 5, 10, things that are easily multiplied so that it's easy for you, any other person that might be reading your graph, to understand how exactly you went about it. Using numbers such as 0.4 and 3 and 2.8 for your scale can become very cumbersome and very time consuming as you try to make your way through. So do your best to stick with easy numbers. Now, scaling your graph can be a little bit complicated, okay? But it's not something that we won't be able to overcome with practice. So please, 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 if you have questions along the way, just make sure that you ask. Next up, once we've put our scales on our graph, we want to make sure that we're labeling our axes appropriately. So my x-axis is my time, my y-axis is my distance. Once I have that, I've not only put my name there of my physical quantity, but just as I did in the titles of, or the headings on my tables, I include in there the units as well in parentheses right next to it. Once I've got that, again, it's just like going to math class and I go through plotting x and y. So I first plot my 0, 0, then 2.21, 13.62, third data point, fourth data point. You'll notice that some of my data points don't fall exactly on a line. Well, that's because we don't live in an ideal world. Ideally, everything would fall on a grid line. That's not going to be the case in most of the things that we do, so we want to make sure that we do our best to approximate things to the best position that we can. The last thing that we need to do is to go ahead and put a title on our graph. No graph is complete without a title. So, my title is going to be my dependent versus my independent. So distance versus time. So this is a good example of a distance versus time graph. So if I fade away that data table, this right here is an excellent example of a properly constructed data graph. Please make sure, if you have questions along the way or you're unclear about anything that we covered in this video lesson, that you make sure that you ask your instructor for help as soon as possible. We don't want to get caught behind.